Putting aside the philosophy that there should not be a real analysis class, there should only be a topology class, I'll put that aside and try to go over what real analysis is. If I had to describe it to someone, it's a class about limits. So if you had to say, like, if you had to tell another, a plebe what this class is about, it's about limits. And just end the conversation there. They don't want to know more. So when I was raising my kids, we had a number line that was run across the floor. I had them build a number line so that they can actually walk from number to number integers. So we started out with natural numbers. So my son actually went through this, and he was in my foundations class. And I was telling everybody we did this when he was a child, and everybody looked so sorrowfully at him at that moment. And I told him later, like, I could have told them I was giving you crack cocaine, and they would have not looked at you as sadly as I did that day when I said, this is what we did in our house. But we actually rolled out, and we initially had them mark all the natural numbers. So this was, Ajay had to do that first. And then I believe in putting all the integers on there on the number line right away, because one day you'll have kids. Children start moving away from math with negative numbers. So they think of it as something different. But on a number line, it's just walking one direction and walking in the other direction. So from day one, we had the integers up with the dots, and it goes on forever, and the concept of infinity. So teach them how to count, give them the whole infinite number line and the concept of integers right away. Do this for your kids. I don't think my kids are thanking me yet, but they will one day. Then you went to the rationals. You started working with rationals, I think, 4th or 5th grade. They do things earlier these days, right? They move things earlier, but rationals, we call it Q with the symbol Q for quotient. So those are the set of P over Q such that Q is not 0 and P and Q are integers. And that's a pretty big set. But actually there's as many things in that set as there are in the integers, which is amazing. Because I like to also ask my kids questions in the car when we're driving, which we always are because we were in New Jersey. What's the first rational number after 0? And one kid will always say 1. And I'll say, well, what about 1/2? So can you identify what the first rational number is after 0? Nobody can? Because whatever you do, whatever you give me, I'm going to divide that by 2 and get one that's closer to 0. So there's a heck of a lot of things in the rational numbers that you can twist the mind of a child with. I'm twisting your mind right now. And yet, there's only as many things in the rationals as there are in the integers. If we have time, we might go over that. There's a nice talk that one of my colleagues gave to my foundations class a few years ago. My foundations has already seen this. But showing that the rational numbers are just the same number of elements as the natural numbers. Your class is about the real numbers, and you've been working with the real numbers to the point of fatigue. You started out with, algebra over the reals. It includes the rational numbers, but one thing that it includes that the rational numbers didn't are limits of sequences. So R is what we call the completion of Q, undertaking limits. That's really what it is. So like with a number line, I like to tell my children, there's holes in here. You can't see them, but there are holes in here. So when you get into freshman algebra, you're actually working over a set where you colored in those holes with limits. Never too early to tell your kid what limits are. The first class I taught after West Point, leaving here, was mathematics for elementary school teachers. I'm like, oh my God, they assigned me this class. I've never taught elementary school. I wasn't even good at math in elementary school. I don't think I should be teaching this class. But I really started thinking about, why children don't learn mathematics well and what could help them growing up. And then I had my own kids. I had like an experiment waiting to happen. Ajay was an ASDS major, so something went right. Oh, I just want to mention, there's one more, the complex numbers. How many of you worked with complex analysis? You have with Ted, Dr. Ted. So complex numbers, you probably thought of them as imaginary numbers. That's a bad name to call them. It makes it sound like it's nothing. It's something that's out there, but it's not actually. It's actually the completion of the rationals for roots. So what we care about in algebra, like if you had abstract algebra and I had explained what that is to a plebe, I'd say finding roots. That's what we're doing, we're finding roots. Don't ask any more questions. Really what you're interested in is solving equations and finding roots. So this innocent looking equation, x squared plus 1 is equal to 0, has coefficients that belong to integers even, natural numbers even, but doesn't have a solution even in the rationals. So if you toss in all the things that give solutions to stuff like this, just this equation, and all combinations, what you'll get is the complex numbers. So we have something called a field. So this is a field extension. So the field extension that includes I and the roots of polynomials with coefficients in Q ends up being the algebraic completion of Q, and that's C. So the real numbers is not an algebra object, which is strange because that's what you've been doing over the whole time. You've been using the reals as you use it as an algebraic thing, but it's not. You can completely bypass art and never think about it again if you're taking an abstract algebra class, which I recommend. It's a really good class. So what really bugs me, how many of you took MA 103? Everybody was in Jedi math in here? If you take MA 103, they'll talk about eigenvalues of matrices, but they make the eigenvalues all real, which if you look at polynomial solutions if you make up any square matrix and make it up in your head and then crank out what the eigenvalues are, they're usually going to be complex. So you have complex values. So it drives me crazy to teach that class and not be able to talk about complex numbers, because that's an identification between matrices and complex numbers that has to do with polynomials. It's an algebraic beast. Okay. Questions so far? That's what real analysis is all about, so we can end class today.